So in this video, we are going to continue factoring, and what we're going to be factoring today is called special cases. Now we call it special cases because there is a pattern that you can notice that will help you factor much easier. So let's start with these first two examples here, and I'm going to rewrite them over to the side because I'd like us to work them out slowly so that we can see where that answer came from. So let's go ahead and let's multiply. So I'm going to multiply x times x and get x squared. X times negative 3 gives me negative 3x. 3 times x gives me plus 3x. 3 times negative 3 gives me minus 9. And then when I combine my terms right here, I get negative 3 plus 3, which is 0. So those really disappear. They drop out because 0 is not necessary to be written, and we get x squared minus 9. Okay, so let's do the other one over here to the side. So I've got x minus 4 times x plus 4. Okay, so then distribute again. So x and x gives me x squared. X times 4 is plus 4x. Negative 4 times x is minus 4x. And then negative 4 and positive 4 multiplied is, negative 16. Let me fix that. So minus 16. And then again, combine your like terms here. So that is going to drop out to be 0. So I have x squared minus 16. So I want you to see that the format of the problem here, these factors are almost identical except one says plus the number, the other says minus. Same thing over here, minus 4 plus 4. So notice what happens every time. You are going to get these factors that combine to add up to 0, and we end up with the x squared minus 9. So I also want you to see, this is called a difference of squares. I want you to see that if I take x squared, it's a perfect square. Okay, if I take x squared and think about what goes into x squared, x times x gives me x squared. 9 is a perfect square. 3 times 3 is 9. So notice and see what's in our parentheses. We start with x times x. Here's the 3 and then positive. Here's the 2 3's to give me 9, and then to make it minus 9, it's plus or minus. So I want to have you analyze this pattern. So the difference of squares, a squared plus b squared is going to factor out to be this. Okay, so let's use our example above. So if I have x squared minus 9, all right? So x squared minus 9, a squared minus b squared. So x squared is a perfect square. It's x times x. 9 is a perfect square. It's 3 times 3. And so in my parentheses, I have it written as a plus the factor, a minus the factor. So I can have x plus 3, x minus 3. And so that is going to be my factor. So I'm looking for the same variable squared and then a number squared. And as long as it's a subtraction sign in here, I can factor it in the format of the a plus b, a minus b. Okay, so it's called the difference of squares. And going back to why we can do that is because the middle terms are going to always add up to 0. Okay, so we're looking for numbers that are perfect squares when we do this type of factoring. Okay, so first couple is what we have above. So what I see here, there is, well, first of all, I need to ask myself, is there a GCF, question mark. So always look for a GCF. If there is one, you will need to factor that out. So m squared minus 16, there is no GCF here, so I can skip that step. So I am looking at m squared is a perfect square. It's m times m. 16 is a perfect square because it's 4 times 4. So I can do this format right here. Okay, so I can factor it out. I'm going to have m times m. I'm going to have 4 times 4. And notice there's no just term with an m in it. I'm going to make it drop out by saying positive or negative, plus or minus. Okay, and so here is my answer. Okay, Second one, again, the other thing I'm going to add a note here. No, I'm going to say middle term. It's not a very good description. Put a little star there. So like if you had x squared plus 4x plus 4, this is going to be your middle term. Oops, that's not a very good color. That didn't show up very well, did it? I don't know. Let's try this really kind of chartreuse color. That's better. All right, so there's going to be no middle term. So when I analyze this problem, I don't have a middle term, okay? And so what I see is perfect square on the x times x, perfect square on the 9, 3 times 3. So I can jump into my factoring, x times x, 3 times 3, and since the middle term needs to go away, it'll say plus or minus. Okay, so what if you don't know your perfect squares very well? You can use your calculator to determine if you have a perfect square. So if I take in my calculator the square root of 16 and I get a whole number, that means 16 is a perfect square. Okay, so if I take the square root of 9 and I get 3, that means 9 is a perfect square because it's 3 times 3. If I get a decimal, it is not a perfect square. Okay, like for example, the square root of 20 is a decimal, so that is not a perfect square. So that's why this is called, going back here to the top, the difference of squares, because you are given the difference, the subtraction between two perfect squares. Okay, number 2. Question number 1, is there a GCF? And no, there is not one. Okay, so when I look at this, I see the subtraction sign. So I know that with the b squared, that's b times b. I know 9 is a perfect square. It's 3 times 3. Okay, so I am going to start out 3b and 3b, because if I multiply them back, 3 times 3 is 9, b times b is b squared. Okay, 100 is a perfect square. If you need to put it in your calculator, do that, because that 100 is 10 times 10. 10 and 10, and I need the middle term to drop out, so I need to have plus or minus. And that's our solution. All right, try number 4. Go ahead and pause if you need to, but work through number 4. Okay, perfect squares. 2 times 2 is 4, x times x is x. Okay, you may not know that 121 is a perfect square. So if you take the square root of 121, you get 11. That means 11 times 11 is 121. So I can do a difference of squares. 2x times 2x, 11 times 11. 1 is plus and 1 is minus. Now, it doesn't matter if I put the minus sign in the first set of parentheses and the plus sign in the second. I'm going to get the same answer. Okay, number 3, is there a GCF? Yes, I can divide a 5 out of the expression. So let's start there by dividing a 5 out of both. 45 divided by 5 is 9. Okay, now I'm going to do the difference of squares just off of x squared minus 9. So bring your 5 down. It has to be in front of your factors. All right, so I know x times x is x squared. 3 times 3 is 9. 1 should be plus, 1 should be minus to make that middle term drop away. Okay, I would like you to pause and continue on. I'd like you to do letter B and go to the next page. I want you to get as far as you can. And when you get stuck or if you get finished, come back to the video and let's check over your work. Okay, I have a GCF here of 10. So divide your 10 out first, and then I'm factoring that. So that can be a difference of squares, because I know 2 times 2 is 4. So x, 2, 2, and then 1 says plus, 1 says minus. And that's it. Okay, GCF. So I know there's at least a 2, because 8 and 50 are both even. 4. No, a 4 doesn't go into 50. All right, so let's take the 2 out. So I'm left with 4y squared. 50 divided by 2 is 25. All right, do I have a difference of squares here? Yeah, 2 times 2 is 4. 5 times 5 is 25. All right, so let's do our factoring. So I've got 2y and 2y, and then 5 and 5, and then I'll have a plus and a minus in there. And there's my factored answer. Let's see, 3 looks like it's the GCF. Yeah, 3 goes into 75. All right, so 3 and then parentheses c squared, that's going to be 25, minus 25. Difference of squares, I've got 5 and 5 and c, so I need my 3. C and C, 5, 5, one says plus, one says minus. Okay, GCF, no, because I have a 1 over there. This is a perfect square. The square root of 36 is 6. So 6 times 6. 1 is a perfect square because 1 times 1 is 1. All right, so let's jump into our factors. I've got 6y and 6y, 1 and 1, and then I need 1 to be plus and 1 to be minus because that middle term is gone. Okay, GCF, yeah, a 7 will go into 28. So 7, that's going to be 4k squared minus 1. And then difference of squares will work. 2 and 2 is 4. 1 and 1 is 1. All right, so 7, 2k and 2k, 1 times 1, 1 is plus, 1 is minus. Okay, so difference of squares can be very easy. You just have to recognize, I'm going to go back to the top. There is no middle term, and what I mean by that is there's no just a number times x. And you need perfect squares, like on this one, number 1. 1 and 1, 4 and 4, so I can do my difference of squares. Okay, if you have questions, please let me know.